Hello and welcome back to SciTech. In this video, I'm going to show you how to make this really unusual musical instrument, which I call the Springy musical thingy. Let's get started. And these are the items that you're going to need to make for this project. And this right here is the schematic to make for this project. In a previous video, I made a 5x5 timer piano with using the same schematic. And this is what it looks like. And this is what it sounds like. The items you're going to need is these mercury tilt switches, which will be the keys to play this instrument. You're also going to need a 2-watt 8-ohm speaker. Also you'll need is a 104 nanofarad ceramic capacitor, a 5 nanofarad ceramic capacitor, a 22 microfarad electrolytic capacitor, and a 5x5 timer, a 10k ohm resistor, and these two perf boards. This larger perf board will go to the mercury tilt switches, and it'll go to these resistors, which will play the different notes. This perf board will go to this circuit, which will be the 5x5 timer circuit, and the type of resistors that you're going to need to play the musical notes of this instrument is going to be a 6.8k ohm resistor, 4.7k ohm resistor, 3.3k ohm resistor, 3.3k ohm resistor, 4.7k ohm resistor, 2.2k ohm resistor, 6.8k ohm resistor, 5.6k ohm resistor, and a 2.2k ohm resistor. And now let's assemble the circuit. To save time in this video to make the video shorter, here's a sped up view of how to make this 5x5 timer circuit. And there we go. This is what the circuit looks like when complete. Next, I'm going to take my two wires, which has no polarity, and solder it to the positive and negative to my speaker. There we go, solder the wires into place just like that. And there we go, solder the wires into place just like that. Since I've already got the 5x5 timer circuit complete, next thing I want to do is create the keys for this circuit. Next, I'm going to take my mercury tilt switches and I'm going to cut the wire right here, just like this. Why I did that is because the wire has enough tension to stay stiff, and by touching it, it causes the mercury to bounce around, just like that. And I want to repeat the same process with the rest of them. There we go, it should look just like this. Next, I'm going to copy my schematic and place all of the resistors into place, just like this. Next, I'm going to follow my schematic and place my resistors in the correct position. Put them on the perf board, just like this. Next, I'm going to take my mercury tilt switch and place them in just like that between each of the resistors. But first, I want to solder my resistors into place. There we go, soldered into place, and cut off the excess. Next, I'm going to solder bridge each of the resistors together. There we go, solder bridge together, and it should look just like this. Next, I'm going to take my mercury tilt switches, remove the insulation, and put them into position, just like this. And then solder it into place. And then solder bridge it to the resistor. And as you can see, my mercury tilt switches has one lead connected to the resistors, and the other lead is not connected to anything. That's because I'm going to do a solder bridge where I connect all of those leads that are not connected, and I'm going to connect them all together, so that way I can make them all connect to VCC, or to positive. Next, I'm going to twist all of my mercury tilt switches to make more tension on the wire and to make it spring better. Repeat the same process on all of them. And it shall look just like this. Next, I'm going to take my 4.7 k ohm resistor and connect it to the 3.3 k ohm resistor. Just like that. Solder it into place and then solder bridge it to 3.3. Next, I'm going to take my 6.8 k ohm resistor and connect it to the 4.7 k ohm resistor. Put it into place, solder it into place, cut off the excess, bend the lead over, and now solder it into place. 6.8 k ohm resistor is now connected to the 4.7 k ohm resistor. Next, I'm going to take this bare wire and I'm going to connect it to all of those mercury tilt switches that are not connected, which are these ones here. Place it in just like that, and now solder bridge it together. And there we go, should look just like this. Next, I'm going to take these two wires and I'm going to use this yellow wire, which I call the signal wire, and I'm going to solder it to the 6.8 k ohm resistor, which will then connect to pin 7 on the 505 timer. Next, I'll take this red wire, which will be positive, and I'm going to connect it to all of those mercury tilt switches, which I said will connect to VCC. Solder it into place, just like that. And there, VCC is now ready. Solder the signal wire, bend over the lead of that resistor, and there we go, the 6.8 k ohm resistor is ready to connect to pin 7. And there we go, it should look just like this. And according to the schematic, if I were to follow the signal wire that's connected to 6.8 k ohm resistor, it will go over and connect to pin 7 of the 555 timer. And if I follow the VCC wire, which is positive, it'll connect to pin 8 of the 555 timer. And now it's time to connect the two circuits together. I'm going to take the positive wire and connect that to pin 8, which is VCC. And I'm going to place it right here. Solder it into place and then solder bridge it to pin 8. There we go. And now the positive is connected to the VCC. Next, I'll take my signal wire and connect it to the 10 k ohm resistor, which will connect to pin 7 of the 555 timer. Bend the wire over, just like that. And now solder it into place and then solder bridge it to pin 7 and 10 k ohm resistor. And there you have it, the circuit is now complete. Now let's go ahead and test it out and see how it sounds and see how it works. Connect my 9-volt battery. Whoa, already. There we go. Now if I hold it this way, just tilt it a little bit, and I should be able to play the notes. Also do this too. This thing is very amusing. Okay, I can literally do this all day, but this thing is really cool now. Now, what I need to do is I need to build a housing so I don't have to keep holding it like this. And these are the items that you're going to need to make for the housing of this circuit. First, I'm going to start with these pieces of cardboard. I'm going to take my hot glue gun and put a little bit of hot glue right here on this corner. Take this piece of cardboard and glue it into place. And then do the same thing on the opposite side. There we go, should look just like this. Next, I'm going to place some hot glue in the center, and then glue in my speaker. And then I'm going to take more hot glue and glue in the speaker on the side of these pieces of cardboard. And there we go, should look just like this. Repeat the same process on the opposite side. Next, I'm going to place some more hot glue on the top of this piece of cardboard. And on top of the speaker, and on top of that piece of cardboard. Take my cardboard and put it on top, just like that. There we go, the speaker is now securely in place. And it should look just like this. And now it's time to glue the circuit into place. Take some hot glue, place the circuit in just like that. Take some more hot glue and place it next to the circuit. And I'm going to take my 9-volt battery connector and place it on top, just like that. Next, I'm going to take my slide switch and I'm going to go and glue it right here on the side. I'm going to cut the positive wire, remove the insulation, and then solder it to the switch, just like that. And now glue the switch into place, just like this. Put some more hot glue underneath the switch to hold it into place better. Take some more hot glue and put some hot glue on those two corners and place those two pieces of cardboard just like this. I'm going to take some more hot glue and put it on top. And then take this piece of cardboard, which will be the keyboard, and place it on top just like that. Put some more hot glue to secure it into place. And there we go, almost complete. But first, I noticed this is a little bit wobbly, so I'm going to need to add some support structure. I'm going to take these two pieces of cardboard, place one right about here, glue it into place, repeat the same process on the opposite side, and there, now it's more sturdy. Next, I'm going to take my mercury tilt switch keyboard, and I'm going to go and place it right on top. So I'm going to go ahead and put it underneath, and then place it right here. There we go, glue it into place. And there, she'll look just like this. Next, I'm going to take these small pieces of cardboard and put them in between each of the mercury tilt switches. Doing that will prevent the mercury tilt switches from tangling or touching each other when you're playing the musical instrument. Place it in just like that, and it should look just like this. And as you can see, all of the mercury tilt switches, I've bent all the wires and moved them all spaced apart so that way they don't all touch each other. And there you have it. The musical instrument is now complete, and now it's time to place the battery inside, and it's time to test the circuit out. And now turn on the switch. Is you hold it like this, and just do this. You could even tilt it like this to change the rhythm. So hold it like this so it sounds like that. And there you have it. It plays just like that. And there you have it. Now you know how to make this really unusual musical instrument, which I call Springy Musical Thingy. And there you have it. Thank you for watching Sci-Tech. I hope you learned something new, and don't forget to like and subscribe, and of course click on the bell icon to be notified for future Sci-Tech videos. Till the next tech, goodbye.